This evening, take a look at Raspberry Pi 2 again, this time FreeBSD. This will be FreeBSD kind of what their current is. This is 11. So it's going to all be done through the serial port using serial console. Before starting here, I burned the image onto my micro SD card. It's about 1.1 gigs. So let's fire up terminal here, and I'm going to plug in the power to the Raspberry Pi 2, and hopefully we'll get it to boot. Okay, so it looks like it's auto-detected correctly to put console messages out to the serial console. So it's correctly detected that. Looks like it's putting up the Ethernet adapter. It's found that. It's looks also to be resizing the file system, which is a nice touch. That's certainly what the NetBSD did. The NetBSD image, its behavior. And we'll see if there's any differences here, NetBSD versus FreeBSD, and in terms of usability, etc. I mean, obviously they are different. They share a common ancestor, however. They've diverged a bit, but it'll be interesting to see here. They're on an identical platform. What differences there are between the two, and do either of these compete? So the third video will probably be using a Linux here on this platform. So maybe the Slackware ARM would be my preference, although I certainly could do one of the more common Debian-based, Raspbian or whatever the standard is. So things are going well. It's got DHCP, assigned it IP address, generating some keys. All pretty normal stuff. One thing to note is, micro SD cards, or I guess SD cards in general. I mean, I guess a fast one, this is a fast one, I guess it's 45 megabytes a second, which is slow by modern standards, but quite quick if we were to go back to the 90s. What was that? Fast SCSI 2? I don't know. I'm forgetting my rates, but it's not the fastest thing in the world. Let's see about logging in as root. I think the default password is root. And it is. So that is pretty dandy. Switch over to my other tab here and see if we can get in via the network. There's a FreeBSD account already there. You have FreeBSD and root, I believe. Password there is FreeBSD. Make it easy. Obviously, you're using these in any sort of exposed configuration. Pay attention to security. Let's see. Let's fetch the ports tree. Okay. So the clock is wrong. So what is today? Yeah, bad format here. Okay, so now we've set the date. Hopefully it'll be able to fetch the ports tree successfully, and it looks like it is. Chugging along there. Let's switch back over to the other tab. And is the FreeBSD user a member of the wheel group? And he is. What's a good package to see what packages are out there? Let's put one of my favorite editors on there. Let's put Jed out there. Seems to be working so far, and that's a nice touch. At least the install image for the image provided for NetBSD did not have a package path defined. Not a huge deal, right? You can go set the package path, but it's an additional step. So right out of the box, you can go and add packages and grab ports pretty easily. Ooh, that's not good. So missing some libraries. Interesting. I bear in mind, I do not recommend doing this. It's a little slow here. So yes, this is not recommended, but this hopefully will. So there are some package issues here out of the box. So one of the things, again, to note is I'm using the image of current. So this is version 11. So that's kind of the current. This is the November 2nd build. So a little kludge there. Seems to have gotten package up and running. So far, performance-wise, again, it's roughly similar. See how fetching the ports tree is coming. Okay, it's extracting. And that's one issue, I think, with the Raspberry Pis. And one thing to note is probably get some better performance by hanging some storage off the USB port. So a nice, fast USB stick, or hell, even a real drive. Put that off the USB port because the SD card is slow. And I think that's a good bulk of the reason why I'm experiencing some slowdowns. But I think processing-wise, the thing's pretty capable. And I think we're talking about, what is it, 1,000 MIPS per core, and on Raspberry Pi 2 you get 4 cores. That's pretty decent for. What this is designed for is kind of embedded stuff and learning, and I think it's ideal there. So as I said in the previous video, one of the things I'm going to be doing is hanging some USB audio devices off here. So you only have audio out, is putting audio in, and using a graphical programming language called PD, Pure Data, to work out some DSP stuff. So I highly recommend taking a look at PD. Perhaps I'll do a video on PD or Pure Data. Not a huge fan of graphical programming, but there are a couple of cases where I think it is really handy. One is doing kind of data analytics, kind of data science. I'm making finger quotes when I say data science because it's kind of a ridiculous name. But graphical programming environments let you play around with the data very quickly. So you could do that in SQL if you had the data in a database. You certainly could do it with scripting languages, but being able to drop processing nodes and treat your data differently. The graphical environment I like for data is an environment called KNIME. That's KNIME. I find that really handy. So you bring in a spreadsheet, some data from a relational database, you do joins and groups, and put your machine learning algorithms on it there. And for the exploration phase, that works great. Then obviously you may want to move into a real environment and do real code for a production use. But the other one is PD, or pure data, and I use it a lot in the computer music world because it lets you put together synthesizers and effects, and also in the amateur radio world. So one of the things, maybe we'll walk through building some audio filters with that, which is an interesting task. So you can actually play around with different filters. I mean, it's software, I guess, initially designed for computer music and synthesizers, so filters are important. So it's finally moved along here, and seems to be going decently. Let's put this in the background here, and we'll see what's going on the CPU. Yeah, not the speediest. But yeah, as you can see, we have our not using up much memory, and of course, you know, the tar and package are taking everything up. Let's see what the file system layout they gave us is. And as I expected, you just get, you get your boot, which is going to be a fat file system, and then we just have a single root file system with all the remaining capacity, of which only about 700 megs is used. So that is a nice touch, that there's some available. It doesn't take a whole lot. I think that NetBSD was similar. So these so far are roughly equivalent. Again, this isn't a production build, so this isn't a real release, so I can't fault them. But library issues on the package tool is that's an added frustration. But again, as you saw, it can be hacked around pretty easily. Pulling in the packages here, and what else? I'm trying to think of some other stuff to say about this. Let's see if we get our GPIO header. So this should be a similar SD card to the one I have NetBSD on that I did in the previous video. So they both claim to be the 45 meg per second class 10 micro SDs. This one I think is a Patriot. The previous one was a Samsung. So while they should be ideal, there may be some slight differences. So if this seems to the viewer that things are taking a little longer, that could be things related to the operating system. It's not exactly apples to apples because we have a different SD card here. But certainly the disk access seems a little bit slower for what that's worth. Because I don't recall in NetBSD it took this long to get up on packages. I think maybe it took a while to install one of them. I think we're doing GNU Emacs. Okay. So 7 megs of download, 30 megs. So that all looks pretty normal. It's getting a lot of X Windows stuff. Now maybe I forgot where GPIO was, but I thought that would be in here. There we go. For whatever reason, thought it was in all caps. So again, let's see if this looks embedded-ish. and it does. So should be able to do your your GPIO programming right out of the box. I do have to say this does feel a bit slower than NetBSD. So I'm interested to see about whether the Linuxes would have this same performance problem. I have every reason to believe they would. For most of this sort of operation, I typically find the BSDs, at least on PC-style hardware, x64 stuff, to be every bit as fast. You really see the differences when you're running a database dealing with many transactions or a web server. You'll start to expose performance differences at a fine level. And some things can be quite a bit faster on FreeBSD with things like ZFS. That seems to be moving along okay. Port snap is still running. So there you have it. Getting out the ports tree, and that is one advantage that FreeBSD will have, is the FreeBSD ports is in some ways more complete than package source on NetBSD. So bear that in mind. And that is maybe one of the failings where Slackware's ARM situation, because Slackware, you typically add packages, you use a Slack build. It's like ports, if you're not familiar, and you build based on the source release of some package. So if I were to build JED, although that comes in here, but in this example, if there was a Slack build for it, you'd run that. It would download the source, build it, create a package, and then you'd install the package, Slackware package. But I don't know whether Slack builds support the ARM architecture. I think they might just be i386 and x64. But we'll see that. Maybe I'll do a video on that. But yeah, port snap is still going. But hopefully we'll have JED up here in just a couple minutes. So there we have. So we get JED. Do we have a working Perl installed? That is the other question. So we'll find that out here in a second. Oh, so no Perl. I'm trying to remember, did the NetBSD include a Perl? I don't know. I'll have to find that out. Maybe I'll put that in the description below, whether the NetBSD included a Perl. See what version of Perl then. Whew. Okay. 522. See how quick this one. Okay. 13 megs. So that shouldn't take too long. So we'll slap Perl on there. And another interesting point is I don't know if this is because they're pointing us to a different package repository why this is slow, because certainly my network should support much more bandwidth than that, and port snap is still going. So one of the things FreeBSD has in one of their pages on this. Now bear in mind this is the first time I've booted up FreeBSD here on the Raspberry Pi 2, and one of the links I saw there, they do have Perl libs for, a Perl module for doing the GPIO, which I like. Huge fan of Perl. Makes, simple things dead easy, and complicated things possible. It's an amazing language. And that's one of those interesting things. I see all around me the rise of Python, and I don't get it. it's the white space positional language. I mean, that's if you want that, might as well do Fortran, and at least you know Fortran's been around for a while. So I don't get the Python um, appeal. And leave a comment below if you think Python is worthwhile. I don't see it, because in the kind of what people call the quote scripting languages, again, got my finger quotes out. I think Perl's kind of the king, and if you wanted a little bit more proper computer sciencey fun design, maybe Ruby. But Perl's blazing fast, been around forever, has a module to do anything you want. Um, so yeah, don't really understand the appeal of Python. And then if you want, compiled to bytecode, you get Java. I mean, that's an amazing language, and might as well do C or assembler if you want something that's gonna take a while. But yeah, I guess my biggest gripe with Python is that it's not C-based syntax. So, doing C and C-based languages for a long time, you expect curly braces to denote blocks, and not a big deal. Like I say, I do Fortran and Verilog and other things that aren't C-like, but it is popular. So yeah, PortSnap's still chugging along. And this is still chugging along. So a little bit slower. And again, I don't know if I should chalk that up to maybe the SD card is not as fast as advertised. That's a possibility. But certainly the NetBSD felt faster. Or maybe I'm just remembering that with a little bit of rose-colored spectacles. So I have to go back and look at that again. But so far, I mean, this absolutely works. I know it's not a real release. This is kind of a weekly build or whatever that's available. This is version 11 of FreeBSD again, but worth playing around with if you don't want Linux on your Pi, which might be an option. Kind of next up, I think, as I said, would be Slackware, just because I think that'll be fun, and that's a little bit more involved from what I saw. It's you boot your micro SD, and then you also have the installation files on on some USB storage. So it's a little bit more involved. It's not these nice packaged, hey, it boots up, it expands the file system based on your SD card, and you're ready to go. That the NetBSD was that we looked at. I guess it was last weekend, and this FreeBSD, which are kind of there's no installation required. Yeah, let's see what we're doing here. So yeah, nice amount of system time being used. Not a whole lot of I/O actually. So yeah, I know I'm rambling on and keeping there's a little bit of dead air there for a second, but keeping the video open until we get the at least this package installed. There we go. Okay, well, thank you, FreeBSD package maintainers, for putting this in. Everyone should always use in their shebang user bin env, or wherever env is, space Perl. Please do that, and also don't pass arguments to Perl in the shebang line. Okay, and they didn't actually. Did I misread this here? They didn't actually provide. Huh. Interesting. Okay, well, installed Perl. I guess that's it for this video. Not a whole lot else to say. This was just supposed to be a kind of, little boot up video. Uh, and not a whole lot else. So next one up on the Raspberry Pi will be a Linux, and after that, we'll actually start doing some useful work with it. One of the things is waiting on Amazon to get a USB audio device. A big failing here, they didn't put an audio in. You want an audio in. Audio out is handy, but I guess, for a terminal or a TV-based device, it works fine. Again, thanks for listening to this ramble and playing along as I got FreeBSD up and running.